Hello, panel. Thank you so much for giving me this opportunity to present it virtually. I worked on this project but couldn't actually submit it on time. Thank you so much for accommodating my request. Um, so I'll get started on this project. So my project is music recommendation systems on 1 million data set, where I'm trying to find the solution for the problem of where the users, like recommending the users with top 10 songs that they would likely to listen to. And the data set that we're using right now is taste subset, which is a subset of 1 million song data set. The solution that I would like to suggest will be based on what kind of the user that we are dealing with. Let's suppose the user is someone who is new and that doesn't have much data, and then we can go with content based, and we could just go give the recommendations like, okay, this user doesn't have any data right now, so we could just give the recommendations like the popular songs based on every single use, based on the whole data set, like what are the songs which are played mostly. So those can be suggested to the user who are new. And if the user is already in the system and is already using the system for so long and they have the data, then we could go with collaborative filtering based on item-based similarity, or like, or else we could go with some model-based stuff. So here I'm doing a comparison for popularity based and item based, and performance metrics of those two models, and seeing which would do better in this particular scenario, and then come to a conclusion, and then do some recommendations further plays with different models as well. So this particular data set has attributes like song ID, which is the unique thing that actually identifies a song, and it has title, the release, artist name, year, and play count. Play count is something which is important in building the popularity based model or item based model, could be saying, because that is what we are trying to use to get the score for the recommendation score for each song. So these are the steps that I took to come at to the solution for each model that I'm trying to build today. So the steps taken are like, first is data loading and pre-processing stuff, and then next is exploratory data analysis, and next is model selections and building the model. And the next is model evaluation, like generating the recommendations and also evaluating the both models. And the next last step is recommendations for after doing the model comparisons and all that stuff. So skipping the loading data part and pre-processing, what are the things that I have observed doing the stats is, if you actually see like the max play count that we see is 2213, where the third quartile still stays at 3, which is really odd, and this could be a potential outlier, but this is an assumption. So in order to get a proper visual feel like, okay, this is the outlier, we would go for Curtis score and skewness plots, like probability plots, in the next coming slide. So and also you could see like, only 75% of the songs were like played 3 times, and 50% of the song were only played like once, which also says like, the data might be really sparse, and so these are assumptions which needs approve. So let's go and do this skewness and high, this Curtis's plot, which for the songs and the user ID, which says like, if you see this red line, this thing doesn't fit this normal distribution. And also the Curtis score is 32.59, which is says is highly right-tailed and has outliers, potential outliers here. So we have to be really careful here. And so we could, what we have to do we're trying the data is like sort by just the play count and remove these outliers from the data and then get as it is highly sparse as well. So we'll get the a part of this data in order to actually train the models and then do some recommendations based on it. So the recommendations are like 3 types: content based, collaborative filtering, and also hybrid, which employs both. So here I'm trying to do like 3. One of it is popularity based, another is item based, similarity based, score based, similarity score based recommendation, otherwise model based k-means clustering. That is like a further play, but the main 2 ones are like popularity based and item based recommendations. So in the popularity based recommendation, so I did get the top 10 scores for a user, depending upon the play counts of all the songs. And the results for this particular user are like this. As you can see, the title is like Sarah Cosmich has been repeated for like 1, 2, 3, 4 times here. And this could say like it's not actually performing properly on this data. So let's go and see the item based similarity recommendations for the same user. And it sees like there is no single song that has been repeated, or it says, which intuitively says this has been performing better than the popularity based one. So but in order to get a proper hang of this assumption and like confirming this, we'll go with a precision recall curve for the both models and see which is doing better. So I've drawn that, and as we can see, the recall, the precision curve for item similarity model is far way better when compared to the ones with popularity model, which says item similarity model is giving the better results and better recommendations when a user is being passed to this model and what kind of songs that a person would listen to. And that is my suggestion, to go with similarity based model, because that is faster and also giving a user specific recommendations better when compared to the popularity based. And for the play, with different with the model based recommendation, I went with k-means clustering and saw that during due to elbow method using, I got 4 clusters, the 4 k value to be 4, sorry, and then I have done a song recommendation k-means model here, and then for the same user I got like only 4 of the recommendations out of even if I've given 10. I haven't properly actually evaluated this model later, but this is just a further play. But coming to my recommendations, as the data is highly sparse here, I would recommend doing SVD, like with matrix factorization for the further steps, maybe if someone is interested. But considering the models that I've did, I would go with similarity-based collaborative filtering, which gave like more user specific. Even if the data becomes dense, I think this is performing really better than the popularity based. And eliminating or redundant data and the data which is not which is not good for us, and then let's just taking the data which helps us building the model, made it faster and easier, and try using similarity scores between the items, which helps it build the model really well. These are my recommendations, and this is the project I've done. Thank you.